Hello, this is Doug Lewis with a video for Math 107, the Growth Models written assignment. In this assignment you're supposed to go online and find some data of some topic that you think might be changing either linearly or exponentially. So I'm going to give you an example of a couple of things I looked for. I'm going to look at the U.S. national debt over time, so over the last, let's say for the last 10 years, and see what that'll tell me. This gives me the national debt compared to the gross domestic product, which I don't really want that. I want it over time, and here's one that says U.S. national debt stats from 1990 to 2019. That's more than I want, but that's better than nothing. And so, well, I look at that and I go, okay, that might look somewhat exponential to some people, but remember, exponential usually goes flat along the bottom and then curves up and gets steeper and steeper. This doesn't look that flat along the bottom. It actually increases and then goes down here from George Bush Sr., the late George Bush Sr., to Bill Clinton, and then George W. Bush was along here, and then Obama was here, and then Trump started right here. So these are kind of interesting. It's kind of changing in presidencies, actually. But more importantly, I think you'll note, even though the Clinton years were kind of leveling off there, and maybe could have turned down, the dot-com bust went here, and 9/11 was there, and so that really affected the economy. So this is, sometimes historic events affect these graphs, and it's just like, okay, those two events were fairly close together, and bang, it happened right there, and so there's kind of a sharp corner. And then in 2008 to 2009, that was the housing market crashed. Huge blow to the economy. Enormous recession. So we, tried to build the economy back up again, so we went into debt to do that. So that had this big effect right here. And then it started tapering off, and economy improved. And then, then there was another decline here again. So we're just, all kinds of events happen that you can't really predict. And so this is not really a very good model for either linear or exponential. What I did was, since I can go along here and get all the data along here, I just said, well, I want really the last 10 years. So I just went back to 2010. And on this graph, it tells me in 2010 it was 13,561. That must be in billions, because that's 13,561,000 in 2010. And then, so I wrote all that data down on this. And I just showed, I said, well, what if I were going to do a linear model, I would say, well, this is the difference from 13.6 to 14.8. We subtract those two to get 1.2. Then I subtract here to get 1.3, subtract here to get 0.6. And the common difference we find, we look for a common difference by subtracting subsequent terms. And as you can see here, those numbers are pretty inconsistent, 1.2, 1.3, then 0.6, 1.1, 0.4, 1.4. So that's not a very consistent difference between those two, between those as we go down. So I tried the common ratio. Well, maybe there's some exponential function would fit. And so you do that by dividing 14.8 divided by 13.6, and that was 1.08. And then 16.1 divided by 14.8. Oh, look at that. It's very consistent in the first two. But then 16.7 divided by 16.1 is only 1.037. So I can say, well, it's not that consistent. So I continued to divide and got all these values. You can see it's changing quite a bit here, until I thought, well, that doesn't look very consistent either, as I was suspicious of. Actually, after looking at it, I thought, oh, okay, it's really not exponential or linear. So that wouldn't be a great fit. So I'm going to use a different topic. So I like I like basketball, but I think a lot of athletes get paid maybe quite a bit compared to everybody else, obviously, maybe too much. But so I looked up the NBA, salaries. I looked up NBA rookie salaries by year. So I could say for the last 10 years, but I just said by year. And okay, this is the minimum salaries for 2019-2020, NBA minimum for 2018-2019, and then, there's one from 2011 to 2019. So I'm going to select that. That gives me some data there. And, okay, what happened to my NBA salaries? All right. This is covering those up now. So I've actually already done this. This is asking me to log in this time because I've been in before. So I'll try to log in. Yeah. And then it says I did not validate my email address. Okay, it doesn't really like that. So I have all that data anyway. If you look at that, you can't really see that it's hard to tell whether that looks when this is gone. Okay. It's not going to let me see it. I have all that data from that. It looks like it might be linear, and it looks like it might be exponential, or really it looks pretty linear. But when I did all the data, I got all the numbers from the table there, chart there. And so in 2011, the minimum salary is $442.1. It went up to $457.6. That's in thousands. That's $442,100. Then in 2012, it was for $457,600, and that was an increase of $15.5 thousand. That's $1,000, $15,000 difference. And then it went up 16,000 the next year, then up 16.6 the next, and 17. And boy, it looks like it's increasing over and over. So that does not actually look like a common difference. So that means that if we go and look at the common ratio, however, that by dividing 457.6 by 442, I got 1.0351. Then I divide it again, I got 1.03497, then 1.0351. And if you look really carefully, boy, that looks very consistent. So that's a very good fit for an exponential function, these NBA rookie salaries. So I didn't even do any calculating there. I can just look and see that's about 1.035, almost every single one of those. It's a little over, almost exact. I mean, these are so close. So I can just say my B, my constant ratio B, is about 1.035. And so I'm going to use that in my formula. Now 442.1 was my beginning year, and so I write 442.1 times 1.035 to the n power, and n is years since 2011. So in the assignment, you're supposed to predict something in the future, so I'm going to predict the NBA minimum rookie salary in 2040. And so if 2011 is the first year, 2040 minus 2011 is 29 years. So I use this formula. I put the 29 in for n, and we get 442.1 times 1.035 is equal to 1198.9. Well, this is in the millions now, $1,198,900. So I just said, well, that's pretty close. This is an estimate anyway. That's pretty close to 1,200,000. So in about 2040, I'm guessing the rookie salary might be close to 1.2 million. That's a long way out. Might have been better to predict something like in 2025 or 2030. The NBA might change quite a bit between now and 2040, we don't know. So that's maybe too large of an extrapolation, looking too far ahead. Anyway, that's how you would do that. Okay? Make sure you show the consistency of your ratio if you use an exponential. Make sure you show a consistency of the difference, common difference, if you use a linear. So you should show either this data or this data. I'm going to show this data because I used exponential. I don't have to include this in the assignment. Okay? That's all for now.